To ISM 3013 Information Technology Management presentation. This presentation is on Microsoft SQL Server and SQL in general. It is delivered by Charles Woodbury, a student at FSCJ. In this presentation, I will cover 3 questions and cover the history of who developed SQL Server and when they did. Let's start with a question. Why SQL Server is important? Answering this question will provide some clarity on why you are watching this presentation and hopefully give you an aim to focus on as the presentation continues. RDBMS, Relational Database Management Systems, have been a common choice for the storage of information in new databases. Used for financial records, manufacturing and logistical information and personal data and other applications since the 1980s. Relational databases have often replaced legacy hierarchical databases and network databases because they are easier to understand and use. According to research company Gartner, in 2008, 68% of database sites were using Microsoft SQL Server. Long ago, we had file cabinets. And in file cabinets, we had files, usually a folder with many records, and on those records, many fields. So when we developed software programs like Excel to hold these fields, records, and files in a digital format, we reduced paper and overhead. By making these files available to multiple computers or even multiple networks is where we needed database management software that could store and allow the data to be analyzed and information to be gained. Where is that file at? And when you end up with the customer complaint of all complaints you could get or get the Microsoft account, well, as you can see, updating to digital files is what every business needs. SQL Server is a key player in making sure that businesses have the up-to-date information and correct information. They are extremely important for web-based businesses, but are nearly as important to any business. With their use, companies begin to understand their clients, their employees themselves, and even their competition. Now let's talk about the history of SQL Server. A long time ago, somewhere maybe far, far away, database wars. Microsoft was on the verge of database annihilation. Well, not really, but they wanted in the game. So in 1988, 9 years after Oracle, Microsoft began developing a variant of Sybase SQL Server for IBM. They joined with Ashton Tate and Sybase in this venture, creating the very first version of Microsoft's SQL Server. Microsoft began the investment and venture to compete with Oracle, IBM, and even Sybase themselves. In 1996, the success of Microsoft SQL Server prompted Sybase to change their product to Adaptive Server Enterprise to distinguish themselves from Microsoft's SQL Server. The Sphinx. Beginning in 1996, the version 6.5 at Microsoft SQL, Microsoft began using code names to distinguish the projects and to update SQL. 1996 saw the Hydra as its code name, but it was in 1998 that saw a major rewrite using C++ of the older Sybase engine, which was coded in C. Data pages were enlarged from 2,000 bytes to 8,000 bytes. Extents thereby grew from 16,000 bytes to 64,000 bytes. User mode scheduling was introduced to handle SQL Server threads better than Windows preemptive multi-threading. SQL Server 7.0 also introduced a multi-dimensional database product called SQL OLAP Services. Yukon Cornelius. Yukon SQL Server 2005. Since SQL Server 2000 included more modifications and extensions to the Sybase codebase, by SQL Server 2005, the legacy Sybase had been completely rewritten. SQL Server 2005, formerly codenamed Yukon, released in November 2005. It included native support for managing XML data in addition to relational data. SQL Server 2005 added some extensions to the T-SQL language. to allow embedding xquery queries in T-SQL. In addition, it also defines a new extension to xquery called XML DML that allows query-based modifications to XML data. SQL Server 2005 also allows a database server to be exposed over web servicing using tabular data stream TDS packets encapsulated with SOAP protocol requests. When the data is accessed over web services, results are returned as XML. Then we have Common Language Runtime Integrated. Was introduced with this version, enabling one to write SQL code as managed code by the CLR. SQL CLR was introduced with SQL Server 2005 to let it integrate with the .NET framework. SQL Server 2005 introduced multi-version concurrency control MVCC. User-facing features include new transition isolation level called snapshot and a variation of read committed isolation level based on statement level data snapshots. SQL Server 2005 also introduced MARS, a method of allowing uses of database connections for multiple purposes, and it also introduced DMVs. These stand for multiple active result sets and dynamic management views. Service Pack 1 of SQL Server 2005 introduced database mirroring, a high availability option that provides redundancy and failover capabilities at the database level. Extended support for SQL Server 2005 ended April 12, 2016. Make no mistake, this move was as boss as Yukon Cornelius doing root canals on a bumble with a pickaxe. Here you can see the code names in the different versions of SQL and their launch years. You may notice that often there is a 2 to 3 year gap between versions. From Yukon to the in development Helsinki, Microsoft has owned this version. If you plan on or are taking Introduction to SQL at FSCJ, you will likely use either SQL Server 2012 or SQL Server 2014. Now that we know why it's important, how it came to be, how does it work? First, we need to understand what the SQL part of SQL Server stands for. SQL is an abbreviation for Structured Query Language. At its core, it is a language, meaning it has established rules and procedures which make it recognizable and useful. However, unlike English or Spanish, the goal of SQL is not to communicate with another person, but with tables, records, and databases of information or data. For instance, in our picture here, we have a wordplay with the use of the word join. Join in SQL is a command term to combine tables together to create one table. So now we have a brief overview of what SQL is. How does it impact memory storage and data manipulation like I referred to in the beginning? SQL Server uses a buffer management system as part of inputting, updating, or removing data from the database. It also uses form of SQL for querying data into information tables. This version or dialect of SQL is called TSQL. There are some other SQL dialects SQL Server uses, such as SQL Native Client or SNAC and SQL CLR, but the main one used for communicating across the network is T-SQL. SQL Server allows for rapid data transfer and updates by retaining a backup we call a transaction log. Now the log isn't a complete backup, rather it is a log of the changes being requested and the time it was requested. This is done in case of power failure, network failure, and other fails that may prevent the data from being moved. Also doing this for multiple updates to take place congruently or in succession without slowing down the database server. To do this, SQL Server stores memory on RAM. By combining RAM with the transaction log, we can know all the data transfers and their integrity. As I mentioned earlier, SQL mainly uses T-SQL for network query pools, but also has a few other dialects of SQL it uses. T-SQL uses keywords to identify the ask of a query and sends the results over the error if the query results in 1. Back to the client or requester. SQL Server can be managed using only T-SQL, by producing read-only tables. Rules and procedures can also be stored via T-SQL to invoke rules or regulations automatically on future requests for data in a table or tables. Now let's briefly discuss the other two dialects. Snack is used to help run the database and server relations locally. It plays a key part in running behind the scenes on non-active query requests. SQL CLR is used specifically with .NET network frames. Unlike most other applications that use .NET Framework, SQL Server itself hosts the .NET Framework runtime, i.e. memory, threading, and resource management requirements of .NET Framework are satisfied by SQL OS itself, rather than the underlying Windows operating system. Now let's talk about how SQL impacts businesses and their future. SQL is something that's going to be here till the end of the world. Even with the rise of the big data systems, relational database systems have not lost importance. RDB-MBS will eventually be augmented to follow the object-oriented databases. We are already seeing some of this now in companies like Amazon, Walmart, and even Samsung, where invoices are attached as an object scanned and included in the dataset. SQL technicians are in demand, especially as companies customize their own databases and servers. Data storage has become mobile, making it a priority to maintain, update, and secure. If an organization moves database to the cloud, you must make sure you'll be able to recover the company's data, as well as access it when needed. The network, of course, is the primary conduit for doing that. Thus, issues such as network bandwidth and latency become data recovery and accessibility issues. Last March, Microsoft teamed up with Linux to announce a collaboration between the two companies in support of SQL Server. This was done so that the SQL Server would be able to work more fluidly across platforms and operating systems. SQL Server on Linux was announced in March 2016. This was big news when it happened, and it was mentioned that it would be released sometime in 2017, so this year. Microsoft announced support for graph functionality and adaptive query execution for Azure SQL database at PASS Summit in October, which is usually an indication that those features are coming to the on-premises product. Microsoft is supporting many Linux platforms, including Red Hat Enterprise, Linux Ubuntu, and Docker containers. The SQL Server Docker containers allow a developer running on a MacBook to use Visual Studio Code developed against SQL Server in a Windows-free environment. Why is SQL Server important? It helps companies make use of relational database management, thus allowing to run more profitable businesses. SQL Server was developed by Microsoft and Sybase, continues to be updated by Microsoft to this day. SQL Server works by using a unique buffer management system and its own dialect of SQL. SQL is here to stay because RDB-MBS is here to stay. So we need one to do the other. Microsoft continues to make investments in this tool, which is great for managing information and data in the database. Thank you for your time.